ఇంకా క్లాస్ స్టార్ట్ చేస్తాను.
స్టార్ట్ చేద్దాం. Okay.
So thank you.
Yeah, good evening, Ramesh sir, and good evening, dear students. The screen is visible.
వినపడుతుంది కొంచెం వాయిస్ డ్రాగ్ అవుతుంది. నెక్స్ట్ కొంచెం
సిగ్నల్
కొంచెం అంటే వాయిస్ కొంచెం సాగినట్టు వస్తుంది. స్క్రీన్ ఓకే.
Today we discuss the phase equilibria. Now in phase equilibria, generally we discuss the Gibbs phase rule and one component system, two component system. So these are important aspects in this topic, very small topic, and you might
Sir, screen share
regarding this. అవుతుంది కదా. స్క్రీన్
లేదు సార్.
స్క్రీన్ కనిపిస్తుంది, వైట్ వస్తుంది.
యాక్చువల్గా నోట్స్ సినాప్సిస్
స్టార్టింగ్ లో వచ్చింది.
going to discuss.
ఇప్పుడు ఓకే.
Okay. Discuss equilibrium reactions, and in particular phase equilibrium reactions. రమేష్ సార్ కో-హోస్ట్ చేయండి.
మన మీటింగ్ లో రవీందర్ అని ఉన్నారు, అతను హోస్ట్ మావాడు. సరే, హలో భయ్య.
సార్.
రవీందర్
సార్.
నీకు హోస్ట్ వచ్చింది నాన్న, నువ్వు సార్ని హోస్ట్ చేయ ఒకసారి. కరుణాకర్ సార్ సార్ని హోస్ట్ చేయి. మధ్యలో వెళ్ళిపోయిండు, వేరే వాళ్ళు హోస్ట్ ఎవరినో చేస్తున్నారు. ఫస్ట్ హోస్ట్ ఉండే.
ఓకే అన్న, ఇందాక మొబైల్ డేటా యూజ్ చేశాను, డిస్కనెక్ట్ అవుతుంది, వైఫై కనెక్ట్ చేశాను. ఇప్పుడు ఓకేనా?
Okay.
Right. Okay. Let us continue. I mute all of you. This rule is an important tool used for the quantitative treatment of systems which are in equilibrium. And it also predicts the conditions that are specified for a system to exhibit equilibrium, which means which conditions it requires for that equilibrium. So normally we will learn in this phase equilibria, the quantitative treatment of systems in equilibrium, and also the conditions for the system to exhibit equilibrium. And Gibbs gave this phase rule for investigating heterogeneous equilibria. So the phase rule for systems in complete internal equilibrium. This is the equation of Gibbs phase rule. F equal to C minus P plus 2. You know very well, it's a familiar equation. That is Gibbs phase rule, which is applicable for equilibrium, which are the phase equilibrium. And in this equation, if you know the, try to remember or try to know the terms. C is the number of components and P is the number of phases. Number of phases. And F is the number of degrees of freedom. Simple equation, which is Gibbs phase rule equation, which is applicable for equilibrium reactions or equilibrium, the phase equilibrium systems. So F equal to C minus P plus 2. Now let us see, let us know what are meant by what is phase, what is component, and how we can understand. And let us see some examples. Now what is phase? It is defined as any homogeneous and physically distinct part of system which is bounded by a surface and is mechanically separable from other parts of the system. See once again, it's a homogeneous and physically distinct part of the system which is bounded by a surface and is mechanically separable from other parts of the system. And if you see the example, the decomposition of calcium carbonate, which gives calcium oxide and carbon dioxide. The two solid phases and one gaseous phase. So which means there are three distinct phases. One is calcium carbonate solid phase, and another one is calcium oxide solid phase. Then carbon dioxide gas. And the next one is components. The smallest number of independently variable constraints. The composition of each phase can be expressed in terms of chemical equation. Look at this example. You know water which exists in three phases, that is solid, liquid, gas. And the solid water, which is we call as ice, liquid, and vapor. So when you melt ice, it becomes into liquid. Liquid on heating, it goes into vapor state. And between any two phases, there exists an equilibrium. And if you observe, the composition in each phase is water only. There is no change in composition of water. Simply what it is changing, the phase is changing. So hence it is in all these three phases, it consists only one component. So that's why it is called one component system, where the solid, liquid, vapor are in equilibrium. You can consider any two phases. Okay. So that's about components, phase components. And let us understand the degrees of freedom. It is the number of independent variables such as temperature, pressure, concentration, or composition, so which must be specified in order to define the system completely. అంటే మనం ఏదైనా సిస్టమ్ ను డిఫైన్ చేయాలంటే ఈ ఇండిపెండెంట్ వేరియబుల్స్ ద్వారా చెప్పవచ్చును. Suppose a state of a gas can be explained by the variables pressure and temperature, or pressure and volume. Okay. The state of any gas can be explained by two variables like pressure and temperature, or pressure and volume. So which means here one is kept constant and other two variables. So depending on these two variables, we can express or we can tell the state of that gas. Hence, gas has 2 degrees of freedom, either pressure and temperature. So both are two variables, hence 2 degrees of freedom. Or pressure and volume, also 2 degrees of freedom. So this is degrees of freedom. Phase, component, degrees of freedom. So this frequently we come across these terminology in phase rule. And take H2O, which is in liquid state, is in equilibrium with the vapor water, that is water vapor. And in both these phases, water composition remains as it is H2O. Hence, it is a one component system. The composition of water is not changing. Hence, it is one component system. And it has only 1 degree of freedom, because the temperature known, then pressure automatically specified. Now, if we know the temperature, so hence this phase equilibrium is considered as monovariant. So which means the number of degrees of freedom is 1, which means either temperature or pressure can be mentioned for this equilibrium, phase equilibrium. Hence, it is a monovariant. F equal to 1. Now take this 3 phases. Water, that is ice, solid, liquid, and vapor. So the 3 phases are in equilibrium, isn't it? And these 3 phases coexist only at one particular temperature. So it has no degrees of freedom, which means F equal to 0. The 3 phases coexist at one particular temperature. So hence it has no degrees of freedom. It is called invariant. If F equal to 0, it is called invariant. And this happens at a triple point of water that we'll discuss later in the water system, phase diagram of water system. So is it clear up to this terminology and Gibbs phase rule? And now we use like this, if F equal to 0, F equal to 0 అయింది అనుకోండి, దాన్ని ఏమంటారు? ఇంతకు చూసినట్టు ఇన్వారియంట్. ఇన్వారియంట్ ఎప్పుడు సాధ్యమవుతుంది? when the degrees of freedom is 0, like at a triple point of water, F equal to 0. Hence it is invariant. And when F equal to 1, univariant, like that bivariant and trivariant. Now let us understand, let us illustrate by this explanation of one component system. So which are called one component system? If there is no change in composition of that substance. So such type of systems are considered one component system. So for these systems, the minimum number of phases is 1. So according to the Gibbs phase rule, if we take C as 1, that is one component. If the phase is 1, then 1 minus 1 plus 2, according to
Bivariant, sir.
according to Gibbs phase rule. So we will get F equal to 2. Then F equal to 2 means it is bivariant. So the one component system is bivariant, and the 2 variables are temperature and pressure. Okay. So in that bivariant system, one component system, the 2 variables are temperature and pressure. Now if a one component system has 2 phases, let P equal to 2 in this equation. the same one component system, which means C equal to 1. If we have two phases, for example, liquid water and water vapor, which are in equilibrium, the two phases are in contact with each other. Hence, what do we get? F equal to 1.
One monovariant.
Monovariant. Either temperature or pressure we have to consider. Okay, is it clear? Now let us discuss the phase diagram of water system. Now, as I said, the water system is one component system where the solid ice, liquid water, water vapor, so three phases coexist. In that three phases, any two phases are in equilibrium. Suppose solid and a liquid, and a liquid and a vapor are in equilibrium. Either solid and vapor may be in equilibrium, isn't it? Liquid, vapor, solid, vapor, and solid, liquid. Now, is it clearly visible? కొద్దిగా dim వచ్చినట్టుందమ్మా.
బ్లర్ అవుతుంది సార్ కొంచెం.
షేర్ చేస్తాను, ఆల్రెడీ బుక్ లో ఉంది మీకు, టెక్స్ట్ బుక్ లో కానీ రిఫరెన్స్ బుక్ లో. Now, in this x-axis temperature degree Celsius and y-axis pressure, and this O is called triple point of water. What is that O?
Triple point of water.
Isn't it? Now, if you see the triple point of water, the temperature is 0.0075 degrees Celsius. And the pressure is 4.58 millimeters of mercury. Now, at this pressure and temperature, the three phases coexist. Solid, liquid, vapor coexist at this point. So that is called triple point of water. Now, if you observe the curve OA, which is vapor pressure curve, and OC is fusion curve. That is, when the solid melts, it converts into liquid. And this OB, which is prolongated towards the origin of these two axes, is sublimation curve, where the solid and vapor are in equilibrium. Now look at this, for water at 1 atmosphere, the temperature is 100 degrees Celsius. And at 218 atmospheres, the temperature is 374 degrees Celsius. Okay. Now what, as I said, OA represents the equilibrium between liquid water and vapor. Now for this equilibrium, the component is one, two phases, hence we'll get a F equal to 1. So for this liquid and vapor, F equal to 1. That is univariant. Now here the 100 degrees Celsius temperature at which the vapor pressure becomes equal to 1 atmosphere. That is the boiling point of water. The boiling point of water is 100 degrees Celsius, where the vapor pressure becomes equal to 1 atmosphere, which is atmospheric pressure. Now, similarly, we can explain the other curves, and the other curves also are a highest number of degrees of freedom f equal to 1, that is univariate, isn't it? The OB represents the equilibrium between ice and vapor, that is solid and vapor. It is called the vapor pressure curve of ice. Vapor pressure curve of ice. Here also f equal to 1, which means the number of degrees of freedom is 1. It is a univariate system. And for each temperature, one and only one pressure from that water system phase diagram. And similarly, for each pressure, will have one and only temperature. That particular temperature will have particular pressure, or otherwise at particular pressure we have particular temperature. Now look at that point O. The two curves OA and OB meet. Here the three phases coexist. As I said, it is called the triple point of water. Now here the temperature is 0.0075 degrees Celsius and the pressure is 4.58 millimeters of mercury. Now we can calculate the number of degrees of freedom at the triple point of water. Here the component is 1, but there are three phases coexist: solid, liquid and vapor. And according to Gibbs phase rule, we'll get a 0. That is, number of degrees of freedom is 0. It is invariant. Okay, triple point. So again, OC represents the equilibrium between ice and water. It is called the fusion curve of ice. And it shows the effect of pressure on melting point of ice. So that OC is a, what it is called? Fusion curve of ice. Now for when you observe from this phase diagram, so this fusion curve inclined towards y-axis, which means the melting point of ice is lowered by increase of pressure. So ice యొక్క melting point pressure ను తగ్గిస్తే తగ్గుతుంది. Okay, is it clear up to here? Any doubt, anything you want to ask? These are a very
Nothing.
simple.
Nothing, sir.
Okay. So let us continue for other systems, that is two component systems. Now for two component systems, C equal to 2, isn't it? And according to Gibbs phase rule, F equal to C minus P plus 2. When you substitute C equal to 2, so 2 plus 2, 4 minus P. And for any system which we want to explain it may have the phase 1, minimum number of phases 1. So for one phase, F equal to 3. That means if you substitute P equal to 1, you will get a F equal to 3. So the three variables can be very difficult to draw the graph. Hence, one variable is kept constant. అంటే ఈ 3 వేరియబుల్స్ ద్వారా మనము గ్రాఫ్ గీయడం అనేది కొద్దిగా కష్టం అవుతుంది. సో we can mention any 2 variables, either pressure, temperature. సో ఎప్పుడైతే మనకి ఇక్కడ 3 degrees of freedom ఉన్నప్పుడు ఒకదాన్ని కాన్స్టెంట్ గా ఉంచుతాం. ప్రెషర్, టెంపరేచర్, కాంపోజిషన్. Now suppose if you keep one is constant. ఇప్పుడు ఆ 3 వేరియబుల్స్ లో number of degrees of freedom. Any 2 we have to consider. అప్పుడు when you keep one constant instead of 2 in this Gibbs phase rule, F equal to C minus P plus 1. అంటే ఈ 2 ప్లేస్ లో 1 తీసుకుంటాము. ఎందుకు 1 తీసుకుంటాము? ఒకటి కాన్స్టెంట్ గా ఉంచున్నాము 2 వేరియబుల్స్ లో. కాబట్టి ఇదేమవుతుంది? రెడ్యూస్డ్ ఫేజ్ రూల్ ఈక్వేషన్. Reduced Gibbs phase rule equation for 2 component systems, and in that one variable is kept constant. Now for the 2 component solid liquid equilibria, so we have 2 types of 2 categories we have to understand. ఇందులో 2 కాంపోనెంట్ సిస్టమ్ లో ఏవైతే సాలిడ్ లిక్విడ్ ఈక్విలిబ్రియా ఉన్నాయో వాటిని మళ్ళీ 2 కేటగిరీస్ గా చెప్తాము. ఒకటి, the 2 components are miscible in the liquid state. ఓకే, ఆ 2 కాంపోనెంట్స్ లిక్విడ్ లో మిసిబుల్ అవుతాయి, అంటే కరిగిపోతాయి. మిసిబుల్. And the second category is the 2 components are partially miscible in the liquid state. So one is completely miscible, or we can say miscible in solution or in liquid state. This one, components are miscible in the liquid state. And in this, 2 components are partially miscible in the liquid state. And in the first category, we have again 2 types. One is the 2 components are not miscible in the solid state and form a eutectic mixture. And the second one is the 2 components form a stable compound with a congruent melting point. And the third category is the 2 components form a compound with a incongruent melting point. So these 3 we have from according to the first one, that is the 2 components are miscible in the liquid state. And let us discuss among these that are simple eutectic systems. In this, the two components which forms a eutectic mixture. So let us understand what is meant by the eutectic mixture. So take this, let us discuss this general example which forms a eutectic mixture, eutectic form. Look at this diagram, phase diagram. 100 this on x-axis the composition, on y-axis temperature, which means with the temperature how the composition is changing. So we are observing the composition with the temperature. Now at point A we have 100% A, and at point B we have 100% of B, and at the remaining positions both consist, A and B consist. Suppose at this point A to some extent and most of the B. And this curve, AC curve and CB or BC curve. So in this area, solid A and solution exist. And in this area, BC, below the BC curve, the solid B and solution exist. And this area, ACB, which consists liquid melt or liquid solution. And that the C point C is called eutectic point. And below this D, C, D prime. So we have solid A plus eutectic. And here solid A plus solid B, eutectic. And finally this one is solid B plus eutectic. So let us understand in detail of this diagram, which is simple eutectic system. So the points A, B represents the melting points of A and B. So melting point of A, and this is melting point of B. And on increasing the quantities of B, that is B are added to A, the freezing point of A falls along the AC. ఎప్పుడైతే మనం B యాడ్ చేస్తూ పోతుంటామో మెల్టింగ్ పాయింట్ అనేది ఇట్లా గ్రాడ్యువల్ గా తగ్గుతుంది along the curve AC. The freezing point of A falls along AC. On increasing the addition of B to A, the freezing point of B falls along BC. అంటే B కాంపోనెంట్ కు A యాడ్ చేస్తూ పోతుంటే దాని యొక్క ఫ్రీజింగ్ పాయింట్ ఇలా క్రమంగా తగ్గుతుంది. Now along AC curve, the solid A is in equilibrium with the solution B in A. So this curve, along this curve, solid A is in equilibrium with the solution of A in B. And along AC is called freezing point curve of A. AC curve అనేది freezing point curve. దేని యొక్క freezing point curve? A యొక్క freezing point curve. And along BC, solid B is in equilibrium with the solution of A in B. And again, similar to that earlier one, the BC is called freezing point curve of B. Now, in any of these two curves, AC and BC, there exist two phases, isn't it? One is solid A and another one is solution. Solid, suppose along AC, solid A and solution, two phases. And along BC, solid B and solution exist. The two phases it consists. Now this system is taken at constant pressure. అందుకే మనం ఇక్కడ ఏం తీసుకున్నాము? టెంపరేచర్ అండ్ కాంపోజిషన్. టెంపరేచర్ అండ్ కాంపోజిషన్ తీసుకున్నాం. So it is taken at a constant pressure. Now we apply the reduced phase rule instead of Gibbs phase rule, actual phase rule equation. F equal to C minus P plus 1. Now since it is two component system and number of phases are 2, so the by substituting this in this equation, we'll get F equal to 1, which means monovariant. The number of degrees of freedom is 1, hence it is monovariant. Now look at the point C. Now as I said earlier, it is eutectic point. Now at this point, point C, the solids A and B are in equilibrium with the liquid phase. So which means how many phases are there? 3 phases. Okay, Rama, is it clear? Any one of you respond? Point ఇంతకుముందు phase diagram లో point C దగ్గర ఏముందమ్మా? A and B as well as liquid phase. So which means solid A, solid B and liquid phase are in equilibrium. So number of phases ఏమవుతాయి అక్కడ? 3 phases. Okay na? Am I clear? Does any one of you respond?
Yes, sir. Carry on, sir.
Okay. ఇక్కడ నెంబర్ ఆఫ్ ఫేజెస్ సి పాయింట్ సి దగ్గర నెంబర్ ఆఫ్ ఫేజెస్ ఎన్ని?
3, sir.
3 phases, sir.
So the what do we get? F value
Invariant, sir.
Invariant. So why we have taken this F equal to C minus P plus 1 equation instead of Gibbs phase rule equation?
Two component system.
Yeah, two components. Two components C equal to 2. But why equal to, why here 1, not 2? మామూలుగా గిబ్స్ ఫేజ్ రూల్ ఏంటి? F equal to C minus P plus 2.
Reduced phase rule, sir.
Reduced phase rule. అంటే ఈ 2 వేరియబుల్స్ లో ఒకటి కాన్స్టెంట్ గా ఉంచుతాము 3 వేరియబుల్స్ లో. కాబట్టి F equal to C minus P plus 1. Good. So it is invariant at point C. And again,
sir, reduced phase rule మామూలు నార్మల్ ఫేజ్ రూల్ ఎక్కడ అప్లై చేయాలి సార్? ఓన్లీ వన్ కాంపోనెంట్ సిస్టమ్ కి టూ ది సార్, లేకపోతే టూ కాంపోనెంట్ సిస్టమ్ కి రిడ్యూస్డ్ ఫేజ్ రూల్ అప్లై చేయాలా సార్?
two component systems. One component system normal Gibbs phase rule.
Okay.
Now let us understand this point C again, once again further. So C is lowest temperature at which liquid is in equilibrium with the solids A and B. And it is called eutectic point. What is eutectic point? How we can state the eutectic point, which is the lowest temperature at which liquid is in equilibrium with the both A and B solids, the two components. That is called eutectic point. Eutectic means easily melted. Now area above AC and BC, the two components present as homogeneous liquid solution. ఈ ఏరియాలో ACB అంతా liquid, so that is solution, that is homogeneous solution, homogeneous. Now at this area the P equal to 1, so phase is equal to 1. Which area? ACB, are the areas above curve AC and BC. The two components present as homogeneous liquid solution. So P equal to 1. ఇప్పుడు P equal to 1 సబ్స్టిట్యూట్ చేస్తే ఏమవుతుంది ఇందులో? రెడ్యూస్డ్ ఫేజ్ రూల్ ఈక్వేషన్ లో
2 minus 2 plus 1 equals to 1.
2 minus 1 plus 1. So that F equal to
1.
F equal to
1. Monovariant.
no, no, no.
బైవేరియంట్ సార్, బైవేరియంట్ సార్.
2. F equal to 2 వస్తుంది కదమ్మా.
Or
Look at it once again. P equal to 1 amma. Phase equal to 1. Two component system. The area above AC and BC. The two components present as homogeneous liquid solution. So F equal to C minus P plus 1. 2 minus 1 plus 1. So we'll get F equal to 2.
2 సార్, బైవేరియంట్.
Bivariate. Simple. A very simple topic, easy to remember and easy to understand. The phase rule, only the Gibbs phase rule. Based on that, we have one component system and other two component system. So we can expect simple questions, theoretical questions. Now take a specific example for a simple eutectic system, that is lead silver system. Now, these two metals are completely miscible in liquid state, and they do not give any compound formation. దాంతో కలుస్తాయి కానీ కాంపౌండ్ ఏమీ ఏర్పరచవు. Now take this phase diagram of lead silver system, where on x-axis composition, on y-axis temperature. Now this curve AC curve, and this is BC. Now here at this point 100% lead Pb. Here 100% silver. Now this point A is 327, which is the melting point of lead. The pure lead melts at 327 degrees Celsius. And then similarly, the silver, the melting point is 961 degrees Celsius. Now, to lead, on addition of silver, now it lowers its melting point. AC curve ద్వారా తగ్గుతుంది melting point on addition of silver to lead. Now it reaches a lowest temperature. This lowest temperature is 303 degrees Celsius. That is eutectic point for lead silver system. Okay. So addition of silver lowers its melting point along AC. And AC is freezing point curve of lead. It contains various amounts of silver. Now if you observe at this point C, the composition of silver is 2.6%, which means the remaining is lead. Only 2.6% of silver is present at this point, that is eutectic point.
మరి పాప ఎంత క్యూట్గా ఉంది అంటారు ఇప్పుడు. అయ్యో అనొద్దా?
And pure silver melts at 961 degrees Celsius. Now addition of lead lowers its melting point along BC. So this is pure silver. On addition of lead, its melting point decreases and it reaches at lowest temperature. That is eutectic point. And BC is freezing point curve of silver. And along AC, solid, lead, and solution exist. Along this curve, solid, lead, and solution exist. So which means there are two phases along curve AC. So at constant pressure, there are two phases, two components, hence it is monovariant. Similar as we explained in previous phase diagram. Monovariant. Similarly, Along BC also F equal to 1, which is monovariate. And C is the eutectic point. The three phases, solid lead, solid silver, and solid and liquid solution coexist. At this point, so at this point, F equal to 0, which is invariant. The temperature of eutectic is 303 degrees Celsius. The composition is 2.6% of silver. So once again, let us see this. Let us find the component pressure F degrees of freedom for this equilibrium. You will get a component is 1, phases 3, and F equal to 0, invariant. And take another example, calcium carbonate decomposition. Here two components and 3 phases, solid calcium carbonate, solid calcium oxide, and carbon dioxide. And the degrees of freedom, here we apply F equal to 2 minus 3 plus 2, which is equal to 1, monovariant.
సార్ ఇక్కడ కాంపోనెంట్స్ కూడా 3 రావా సార్?
కాంపోనెంట్స్ 2 ఏనమ్మా. కాల్షియం కార్బోనేట్ లో కాల్షియం ఆక్సైడ్ ఉంటుంది కాబట్టి which is in solid state, we consider it as a 2 component.
సార్ ఇక్కడ కాంపోనెంట్స్ ని ఎలా కన్సిడర్ చేయాలి సార్?
Where
కాల్షియం కార్బోనేట్ లో వచ్చిన
calcium oxide, which is in solid state, which is present in calcium carbonate, and that gives one, that is considered one component, and other one is CO2, the gas, that is second component. So the number of components 2, number of phases 3, and degrees of freedom 1. Suppose take another example. NH4Cl, which is solid, is in equilibrium with ammonia and H2S. These two are gases. So for this, two components, and there are two phases and a degrees of freedom 2.
Sir, components, sir?
Two components.
సార్ ఇందాక క్వశ్చన్ లో కాల్షియం కార్బోనేట్ కాల్షియం ఆక్సైడ్ సాలిడ్ లో ఉన్నా కూడా మనం ఫేజెస్ 3 తీసుకున్నాం కదా సార్, ఇక్కడ 2 ఎందుకు?
ఇందులో అమోనియా అండ్ H2S. On product side, so this and this one phase. Mixture is one phase. Okay, this is solid. When the pressure of ammonia is not equal to pressure of, sorry, not ammonia, H2S, HCl, and H4Cl, it gives ammonia plus HCl, not H2S. Solid, gas, gas. Here the pressure of ammonia is not equal to pressure of HCl. So then only we'll take these two, one phase, and ammonium chloride, one phase. So hence, number of phases are 2.
సార్ ప్రోడక్ట్స్ ని కాంపోనెంట్స్ గా కన్సిడర్ చేయాలా సార్ ఇట్లా ఈక్వేషన్స్? ప్రోడక్ట్స్ ని కాంపోనెంట్స్ గా కన్సిడర్ చేయాలా సార్?
ప్రొడక్ట్స్ రియాక్టెంట్స్ కూడా. H2O solid, H2O liquid. Solid phase లో, liquid phase లో component same. Okay. Okay, Nama, is it clear?
Yes, sir. Carry on, sir.
Which is, this is a very small topic. Gibbs phase rule. Only the The entire topic surrounds based on gift phase rule.
ఇది కొంచెం తక్కువనే కానీ ఇంట్లో వెబ్ సిరీస్ చూస్తా కామెడీ ఇన్స్టాగ్రామ్ టప్ప తీసేస్తారు వాడు మెయిల్ ఐడితో పెడతారు ఇక ఇలా మనకి అడగండి టిక్ అని ఇస్తారు పెట్టుకుంటుంది మేడం దగ్గర ఇస్తారు ఇన్స్టాగ్రామ్ అడగని ఇట్లా
రమేష్ సార్ కంప్లీట్ అయింది.
కంప్లీటా ఓకే అయితే మరి ఎండ్ చేసేద్దాం అయితే చంద్రమౌళి సార్కి కొంచెం టైం పడుతుందంట స్టూడెంట్ పంచాయతీ ఎగ్జామ్స్ ఉంది కానీ ఎగ్జామ్ కి ప్రిపేర్ కండి వాళ్ళ క్లోజ్ చేసేద్దాం భయ్యా మీరు ఎండ్ చేసేయండి ఇంకా 8:30కి ఎగ్జామ్ ఉంది కదా రేపు వి విల్ హ్యావ్ 2 సెషన్స్ ఒకటి థర్మోడైనమిక్స్ కొంచెం ఎర్లీగా స్టార్ట్ చేద్దాం రేపు భయ్యా థ్యాంక్ యూ వన్స్ అగైన్ వీళ్ళైతే ఒకటి క్వశ్చన్ పేపర్ చేయండి వీటన్నిటి కలిపైనా పర్లేదు రైట్ భయ్యా థ్యాంక్ యూ వెరీ మచ్ వన్స్ అగైన్ సో ఫిజికల్ మేజర్ చాప్టర్స్ తీసుకున్నాం స్టూడెంట్స్ జస్ట్ వీఆర్ ఎండింగ్ దిస్ వన్ భయ్యా మీరే హోస్టింగ్ గా ఎండ్ చేసేయండి దెర్ ఇస్ నో క్లాస్ అగైన్ చంద్రమౌళి సార్ క్లాస్ లేదు భయ్యా థ్యాంక్ యూ ఎండ్ చేసేయండి మీరు ఓకే
ఓకేనమ్మా.